The time complexity helps you to compare the performance of different solutions, thus helping you to determine the most efficient solution. This we have already discussed on which factors the time and space complexity depends, right? Like hardware, operating system, the network, and so many things. All right. And the most important thing that you should keep in mind is that we get a time in the form of function f of n. All right. So whenever we find out the time complexity of any algorithm, that will be in the form of a function and not in the form of actual watch time. So you will never get any watch time, exact time after the analysis of algorithm. You will only get a function. All right. Complexities can be constant, logarithmic, linear, quadratic, cubic, and exponential that we are going to see later on. All right, and these are the some decreasing order of complexity. So at the first point, there is O1 time complexity, often called as O of 1. All right, so that is called as constant time. So regardless of the input size, your algorithm will be completed in almost constant time. So that is the best time. So if any algorithm is giving you O of 1 time complexity, you can blindly rely upon that. That is the best algorithm. All right. After that, there comes log n time complexity. If any algorithm is giving you O of log n time complexity, so that is also better. Although it is not best as O of 1 time complexity, but it is slightly below the O of 1. After that, third type is O of n. So O of n is considered as expensive time complexity. Your time will increase as the number of input is increasing. All right. So that is O of n. It depends on the input size. Then comes O of n log n. So O of n itself is expensive, and here we are multiplying it by log n. So that becomes even more expensive than O of n. So next one is O of n square. So this is also expensive. O of n is itself is expensive, and we are making a square of it. So definitely it will be a double of O of n. All right. Here also O of n cube, O of n raised to power 4. So from here onwards, the complexities are very expensive, and they are not desirable. Only thing is up to O of n time complexity we can afford. Next is the time complexity of any algorithm program is not the measure of actual time taken for the program to be executed. Rather, it is the number of times each statement of the logic gets executed to produce the required output. This I already discussed. The time complexity is not dependent on how much exactly time it is required for the program execution. All right, it is not like that, but it is the number of times each statement of the logic that you have written in your program that is going to be executed. How many times that particular line or that particular statement is executed to produce the required output. The time complexity is dependent on this and not the actual time taken. All right. So see this example. It is a simple, very small program written in C language. So here is at the first line we have a main function. So that is just a keyword. Then here we are declaring some variables, that is integer I, and n is equal to 5. All right. So only variable declarations are done here. At the third line we are using a for loop. We have declared a for loop in which I is equal to 1 first. Then I should be less than or equal to n. So value of n is what? 5. Right. So I is starting from 1 and it will be incremented till I is less than or equal to 5. Right. So 1, 2, 3, 4, and 5. 5 times this loop will be executed. When the value of I becomes 6, this condition will become false. The middle condition will become false. That is, I is not equal to I is not less than or equal to 5. Right. So in that case, it will come out of this loop. Otherwise, 5 times this loop is printing only hello. All right. So that is a very simple code. So in the above code, when this code is executed, a compiler shows that the code was executed in 1.16 second. All right. Compiler took 1.16 second for the actual execution. But can we say that this is the time complexity of this code 1.16? No. The time complexity is not 1.16. It is the actual time taken by the program to produce the output. That is very different from the time complexity. Now, what is the time complexity of this program? So it is written at the last paragraph. Rather, the time complexity of this code is dependent on the number of time the statement gets executed. Here, the for loop gets executed n number of times. All right. So that means we will be inside the loop until and unless the value of I is less than or equal to n. So definitely at the max n times this loop is going to be executed, right? N times means 5 times. The value of n is here 5. So we do not consider the constant. All right. We always go for the write it as O of n or O of n square, like that. All right. So this 5 means what? It is a maximum value of n. So therefore, the time complexity of this code is O of n. Right. One swap function we have written here, and there is no for loop present here. So we can simply say that each statement of this code will be executed for 1 unit of time. All right. This assignment will be for 1 unit of time, that is temp equals to a. We are assigning whatever value of a to the temp, and it is happening for 1 time only. All right. So it will be taking 1 unit of time. On the second line, value of b is assigned to a. That will be also happened for 1 time. Then temp value is assigned to b, so it is also happened for 1 time. So total 3 unit of time is taken for executing this code. If there was for loop, then we might have got some time complexity in O of n or log n or n square or n cube. All right, but here there is no for loop, so every statement will be executed for 1 time only. All right. So in that case, we are just adding this unit of time. So 1 plus 1 plus 1, that is 3. So here f of n is equals to 3. So this is the time complexity. Instead of writing 3, what we can write is 3 is what? It is a constant. We are not getting n or log n or n log n or n square, n cube, n raised to power 4. All right. We are getting here a constant time. Right. So that is why it can be declared as O of 1. Here 3 statements, that means 3 units of time. Let us say 1 billion statements, what we will get? 1 billion unit of time. Still that 1 billion is considered as a constant time. So it can be written as O of 1. So this is the example of constant time. Next is this algorithm. Now here we can say that we have a for loop over here. So it is just calculating a sum. Initially s is equals to 0. So this will be executed for 1 time only. All right. This assignment is executed for 1 unit of time only. And it is outside the loop. So it will be executed just once. All right. So we have written here 1. Now here one for loop is taken. This for loop, what it is doing, I is initialized to 0, I equals to 0. I is less than n. Now here value of n is what? It will be supplied by the user through other program. All right. So n times this loop is going to be executed. All right, and I plus plus. So now this assignment, that is I is equals to 0, will be executed only 1 time. So that will take 1 unit of time. Now see here, I is less than n. This is a comparison. And how many times it will be executed? Till the value of I becomes n. All right. So n plus 1 times it is going to be executed. Why n plus 1? Because we are starting from 0 to n, and then I plus plus at the third position we are taking, we are just incrementing it, I plus plus. So it is also executed n times. All right. So 1 plus n plus 1 plus n. So in these complexities, what is the highest time taken? That is n plus 1. All right. This n plus 1 is highest among these three. 1 is smaller, n is also smaller, and n plus 1 is the highest one. So we are considering here highest time, that is n plus 1. Next, we are coming inside this loop. It is going to be executed n times. All right. So as soon as the value becomes n, we will come out of this this loop. All right. So n times this statement is going to be executed. So it is taking n unit of time. And for returning the result, return s. It happens only one time. So it is consuming 1 unit of time. All right. So we can just add these time complexities, that is 1, n plus 1, then n, and this 1. If we add all together, then it will give us f of n as 2n plus 3. So this will be the complexity for this code. So ignoring these 3 and these 2, what remains? That is n. So n times this loop will be going to be executed. The time complexity of this code is O of n. All right. So this is just similar to our previous algorithm. Now see here, this is the example of n square. Now here, in earlier case, we had only one for loop. All right. Now here we are having 2 for loops. So calculating the time complexity as the previous one, n plus 1 is the highest time taken for executing this for loop. All right. For this, it is going to take only 1 unit of time because it is assigning for only once. Right. I plus plus is happening for n times, and this comparison, that is I is less than equal to n, it will be executed for n plus 1 time. And we always keep the highest time, so that is why it is n plus 1. So n plus 1 times this loop is going to be executed. All right. Inside this, there is one more for loop. So as whatever we have done for this outer for loop, it is also true for the inner for loop also. All right. Now here n plus 1 is the maximum time. So for this loop also, there is n plus 1 highest time, right? Because j is equals to 0, this will be executed for once. J plus plus, it will be executed for n times, and j is less than n, it will be executed for n plus 1 time. All right. So keeping the highest time, and that highest time is what? N plus 1, similar to this one, right? So here also we are getting n plus 1, that is highest time, and why it is multiplied by n? So now whatever comes inside this loop, that will be executed for n times, right? So this n is written over here. So n into n plus 1, right? Now see here, C of ij equals to A of ij plus B of ij. This is addition of matrices. All right. So how many times this statement is going to be executed? This will be executed n times for this loop, as well as n times for this outer loop also, right? Because this will be executed for n times. Once the value of j is not equal to n, we will come out of this loop and we will go to the outer loop. Now value of I is incremented, and then we are again coming inside this loop. All right. So again, this will be executed for n times. This statement is executed for n times, right? So 2n times this primary statement will be executed. All right, that is why it is written as n into n. Right. So n into n times this will be executed, n into n plus 1 times this will be executed, and n plus 1 time this will be executed. If we combine these three, if we add these three time complexities, we will get this much time. That is 2n square plus n plus 2. So n plus 1 plus n plus 1, right? So 2n square plus n plus these two constant, this one and this one, that is 2. So 2n square will be, 2n square plus n plus 2. That will be the value of f of n, right? So neglecting the constants and coefficients out of these, so this is constant and this is coefficient, right? So we do not consider these factors, all right? What we consider is the polynomial, right? So the degree of polynomial is 2 here because n is squared here, right? So the degree of polynomial is 2. Hence it can be written as O of n square. So now I hope you got the idea. Now here you might have observed that nowhere we are calculating the actual time. Nowhere we are calculating the actual watch time. What we are calculating here is that number of times a particular statement is executed. All right, and that depends upon the value of n here. N means what? Input value, right? So whatever is the size of your input, execution time may vary, right? So here we are not calculating the actual watch time, but we are calculating the number of times any particular statement in this code is going to be executed. Statement means what? This is one statement. This is another statement. This is another statement. All right. And these opening braces are not a part of this program. I mean, the compiler will not spare any time for this one. Here we are not calculating anything. We are not assigning anything. We are not returning anything. Right. We are just telling the compiler that this is the start of our loop. So there will not be any time involved in opening and closing brackets. All right. But there will be definitely time engaged for executing these statements. That is why, and that also how many times these statements are executed, that will be of our interest. All right. So the time complexity for this is O of n square. Some space complexity. So space complexity is what? The space taken by, or the memory taken by your program for the execution. That tells us the space complexity of your code. All right. Now it will surely dependent on number of variables you are going to use in your program. All right, because these are the factors on which the memory will be dependent. All right, if you are using 100 variables in your program, so obviously 100 different memory locations will be reserved for each variable, right? Whereas here in this code, we are using only 3 variables. All right, that is the swapping function we had seen here. Here we are taking temp variable, then a variable, and then b variable, right? So 3 variables we are using here. So considering that each variable is going to hold 1 unit of memory, right? So 3 variables will hold 3 memory locations, right? So total 3 words. Instead of memory locations, we will call it as words. All right. So here S of n is what? 3. S of n means what? Space complexity of n. That is 3. So here also we are getting the space complexity in terms of a function, right? And not the actual count. So it is 3 here, and 3 is considered as constant. Next, here also the similar code that we had discussed. Now this, what is this? This is a matrix. All right. I hope you understand matrix. So C of ij means what? This I stands for row, number of rows, and j stands for number of columns. All right. So this is a addition of matrices. All right. addition of matrix. So 2 by 2 matrix we are considering here. So I and J, that is 2 by 2, right? 2 rows, 2 columns. So here A, B and C, that is this A, this is one matrix, this is second matrix, and their result will be stored in this C of ij matrix. All right. So 3 2 by 2 matrices we are using here. All right, A, B, and C. So both are n by n matrices, that is 2 by 2, right? So 2 by 2 means what? 2 is the value of n. So we can say that it is taking n square, right? So n square for A, n square for B, and n square for C, right? This much memory is going to be utilized for these three variables. And then 1 unit of memory is utilized for n, I, and j, right? This is I, this is j, and this is n, right? So these three are the variables which are going to hold one word, 1 unit of time. All right. So 1, 1, 1, and for since A, B, and C, these three are the matrices. So to store the matrices inside the memory, you will require more memory, right? So how much memory? That depends upon how much is the dimension for your matrix. 3 by 3 matrix will hold n cube. 4 by 4 matrix will require n raised to power 4. Similarly, here only I and j are there, so we are considering a 2 by 2 matrix. So 2 by 2 means n square. All right. So n square, n square, n square, 1, 1, 1. If we combine, if we add these all memory words, so it will be 3n square plus 2. So n square plus n square plus n square, that will be 3n square plus these 3, 1 plus 1 plus 1. So that is 3n square plus 3. So here also we will neglect the coefficient as well as the constant. So what remains? N square only, right? So it is O of n square. The space complexity for this particular algorithm is O of n square. All right. Here also you can observe that here we have 2 for loops, right? So like here, it depends upon the number of loops. Here it will not be dependent on number of loops here, but it will be dependent on number of variables you are using in your code. Here 3 variables are used and that are taking the matrix memory. All right, so that is why it is n square, n square, n square, and these are the